Welcome back. This is another episode of my series on beat 'em up style games. At the end of last episode, we implemented basic four-way movement. The character was able to move around with different speeds horizontally and vertically. In this episode, we're going to cover character jumping, which in my opinion is the second most complicated aspect of beat 'em up style games, the first being hitbox detection in combat. The good thing about setting up movement with jumping in this genre is that it sets you up to succeed with the hitbox detection, which we'll talk about next episode. Today, we're going to get into the nitty gritty of character jumping in beat 'em up style, building on previous episodes. Be sure to like and subscribe, and if you haven't watched my previous videos on this series, please catch up before you watch this one, as all prior videos build on each other. Let's get into it. But before we do anything, let's discuss where we are and where we're going to be going. Last episode, we were able to move our characters around. In this episode, we're going to have our characters jumping. We used our arrow keys and WASD keys to move around, and we implemented movement through rigid body and physics. We had a level of smoothing so that our characters would slow down a little bit as we let up on the keys based on the level of smoothness that you wanted. And we used vertical speed and horizontal speed because sometimes based on the screen or the setup of your scene, your character might want to move a little bit slower in the vertical space versus the horizontal space. And that was all without jumping. And today we're going to be talking about jumping. For jumping, you'll notice that in beat 'em up style games, characters convey where they're standing in relation to the rest of the screen with a shadow. And if they do jump, then that shadow indicates where they're going to end up landing. And one of the biggest things about combat, which we're going to talk about next episode, is that this shadow conveys where the attacks or certain abilities might land, because oftentimes these abilities are in the horizontal plane, and so the player understands that if they line up horizontally, then most attacks would land. So in relation to the screen, this image on the left, Gauntlet, the character higher up in the screen that is doing a flying kick is lined up horizontally, whereas the other characters are not lined up horizontally and their attacks might not land. On the other screen where the player is jumping and kicking, the person that's in the air is lined up horizontally with the person that is obviously getting kicked. The images that we see here for Castle Crashers and the Simpsons game, Maggie is up in the air, and you know that she's going to land relative to where her shadow is, and that's the same case for the other characters as well. And so if we want to implement jumping for beat 'em up style games, we need to have a portion that is showing the shadow of our character, and that's going to be the root or a base of our character. And then if our character does jump, then we need to have a separate sprite that represents that character, and we need to detach those two things. And when we do move left and right like we did last time, both of them need to stay connected so that when your character does eventually land, they land upon their shadow or their base. How do we actually implement this? Again, we're going to have to separate these two elements, and when they do move around, we're going to coordinate the movement of the shadow and the base, shadow and the main character when they move around, and when they jump, then the main character is going to detach from that shadow and maybe do an attack if they wanted to, play a specific animation. We're going to talk about animations next time, and when they do land, they're going to come back together. So why don't we go and get started. One thing that happened in between this episode and the previous one is that I did a lot of thinking in what we would do for character movement, and I've made some adjustments or revisions to the character movement script. And so I'm linking in the description below a 3 scripts that we're going to be using this episode. So I'll give you a moment to please download those and we'll get started. Hopefully you've downloaded those scripts, and they should be the character movement controls, and player input scripts. If you haven't downloaded them already, please do so. You're going to they're going to override the scripts that we wrote last time, so it's okay if you delete the old character movement script replace it with these three scripts. So the last time that we left off, we had our buckler, and we had basically the same things, but I'm just going to review what we can do now. We had our buckler, and we had obviously a sprite renderer which represented our character, and then we wrote a previous character movement script, and in this case we're going to import this new one and replace it with that. We also had a rigid body 2D, and the parameters here are basically the same that we had last time. We simulated, we had mass, we didn't have gravity scale, because if we had gravity scale then our character would just fall down. And we wanted to have our character movement based on our input. Other than that, we could freeze our rotation so our character doesn't rotate when it bumps into things. And what we're going to do is I want you to replace the character movement and use the new one that we have, and then also add in player input into the scene as well. You'll notice that there's a controls script, and this script actually is just going to be sitting all by itself inside the project folder. We don't need to import it into other objects. We'll talk more about that specifically later when we're going to swap out different types of controls. So I'm sort of anticipating being able to control different characters on the same screen, and so this is one step that I'm taking along the way. So going back to our buckler, we added our character movement script and our player input. In this case, there's going to be two distinctions that I want to make. I want to review what we had for a buckler, and then talk about a character that actually jumps. So this character does not jump at the moment, but I want to show you what we would do if we wanted to have our character not jump and still have our character move around. Let's talk about the first one, player input. So we have the player input script, and it has a couple fields that you need to fill in. This is based on Unity's default, not the new input system, but the default system, and we can look at a couple things. If you're not familiar with this, then we should look at our project settings. Go to edit project settings, and in there you should see an input manager. Inside input manager is Unity's input system, again not the new one but the old one, where you can define what buttons can be used for your input. And by default there's two main ones that we're going to really address. It's going to be horizontal and vertical. And this is where we can set up what types of buttons we want to have that are going to basically control our character left and right. Not jumping, but just left and right. And the things that are important that we need to know is what buttons actually move our character horizontally. Right now you can look at the negative button and positive button. If I press left, then that gives me a negative input for our horizontal factor, and that's going to make our character move to the left. Alternatively, there's an alternative negative button, and that represents A. And if I either press left arrow or A, that's going to move my character to the left. You can remap these if you want to. So if we're going to talk about remapping in a following episode, but this is where you can change these values. So if you don't want A to move your character to the left, then you could set it to something like G or any other letter. The way to make your character move to the right is the positive button, and you can change those from right, which represents the right arrow, or a different key that you want. The other axis is vertical, and this is going to be up and down, and they work this very similar way that we just discussed, but now in the vertical axis. So the critical thing about making this work with this player input script is the way that they spell horizontal and vertical. We know that when we code things that spelling really matters, and so make sure that if you want to make this work with the keys that you have set up in your input manager, make sure that the horizontal and vertical are spelled the same way here. If you don't spell them correctly, then it's not going to take that input based on what you mapped for the positive and negative and alternate positive negative buttons. Cool. So again, this buckler is not a jumping character. So that's the main thing that we need to set up here, the horizontal and vertical. Secondly, we can go over here and look at the character movement script, and we want to check player can move, we're going to have other scripts that are going to control this parameter. But we talked about last episode, there are some times when our character maybe be frozen or maybe taking damage. They are about to be destroyed or die. And so we might disable movement. And by default, we should have this thing checked. Later on, some other behaviors are going to control this. Secondly, this buckler character does not jump, so we want to make sure that this character, this parameter that says does character jump, should remain unchecked. From there, we should drag in the buckler into the object for the buckler into this base RB. Alternatively, you could drag in the rigid body into this field here, and that lets the script know what actually is going to be moving. We're going to be using velocity to make our character move, just like we did last script. And then we can set in the horizontal speed and vertical speed. These 4 parameters should be very similar to what we worked on last episode. So if you hover over does this character jump, you'll notice that there's a tooltip that appears and it says if your character does not jump, ignore all below in the jumping character field. So this buckler does not jump, so we're going to not fill in any other parameters as they won't control any other aspect for this character. And if we hit play, our buckler should be able to move, and it flips, and we can move up and down. And if you want to adjust the movement speeds of the horizontal speed, vertical speed, then you can do all of those things, just like we did last time. So I'll give you a moment to look at my parameters, and they should match up with your character, and they should be able to move no problem. Again, check the spelling for the horizontal axes that you have right here. And then also you're going to fill in all these fields for the rigid body, for the base rigid body, and the horizontal speed, vertical speed to have your character move. Make sure that you have can move checked, and your buckler should move as well. Now we're going to move forward, and we're going to talk about creating a character like we did last. We haven't implemented last time, but we had a character that looked like a turtle. It was Metalhead, I think. We had over here. Let me pull up a sprite. Metalhead, and it was this Ninja Turtle character that we had over here. And I'm gonna show you what it looks like over here to have this thing fully implemented with a shadow to let you see where the character's base is, and we're going to put that all together in this video in very shortly. So I just want to show you that I can have this character move around, and it can jump, and it has this shadow. It's going to come back onto where he is, and while he's in midair, I can move around. Right now I've set it up so that he can jump twice, but that you can change those parameters if you want to. So why don't we go ahead and implement this, and we'll get started. So what we're going to do is we're going to create a brand new object, and this is going to be the overall character that's going to house our turtle and the shadow and the main character that's going to be detached from that shadow. So we're going to go create, and this is going to be, let's call this turtle character. It just has a transform like any other object in a scene. And what we're going to do is we're going to add, let's add an image. A sprite renderer, sorry. Let's add a sprite renderer, and this is going to be our shadow. So I'm going to go down here and try to find that shadow that we had last time. If you didn't have it already, then check the previous episode where, actually I'll put it in the description below, where we have some of these skelly shadows. So I'm going to borrow a skelly shadow from previous episode. Let me just pull this up so you can find it. If you've implemented the skelly, it's called Skelly Just Shadows 60 by 60. You should be able to slice it up and access these base shadows. So there's many of them that you could use, and so I'm just going to pick one and drag it into my sprite renderer here. So I'm just going to go and pull this guy in here like this. Okay, Unity. Oh, I remember why we did this. Let's actually not put this on the base character right here because the scaling is going to be completely bonkers if we don't do this. So we have turtle character, no other thing, and we're going to create an empty child. And this is going to be the base image. And this is, or shadow, you can call it shadow. Probably makes sense to do it that way. Shadow. And then we're going to add a spread render to that. And then drag in one of these shadows from here. Cool. Just like we did the second episode, is that we need to set our sorting layer to characters. And from there, we want to make sure that the position of this thing is relative to our main turtle character. And I'm just going to make this slightly bigger and then reposition it so that it is in relation to my turtle character. Let's see, where is my... Let's just make sure that everything is lined up correctly. One thing that can help you do that is on the turtle character base, the parent of everything, we can put a little dot that's going to represent where our center of our character is. And then from our shadow, I can move this around so that it is right there at the foot. Great. We might have to make the shadow slightly bigger eventually, but that's okay. That's going to be our start of our shadow. We're going to do a couple more things. We're going to add a rigid body to our turtle character, so the root of this thing here. And we are going to do rigid body. (2D). And we're going to set, of course, our gravity scale to 0. This thing is going to be the root of everything. So when we move around, this is going to control the positioning of overall our character. So I'll just shift this down right here like this. Cool. And now we are almost ready. We're going to add a box collider. And this box collider is going to control eventually our hit detection and things like that. And also going to be a landing spot for our turtle when they land. So I'm going to add this box collider. Right now, you can see that it's oversized based on the shadow, which is totally fine. We're going to edit this collider so that it is the bottom half of our shadow and about the same size. We'll be able to adjust the relative width of this thing to fit everything in a moment later, but we just want to get it around here because we don't want this thing to be too tall, because we want our turtle, when it lands, to be standing on top of the shadow, or within the shadow, and not just merely on top of it. Cool. From here, we should be able to select the turtle character, the base object, and add, now that we have the rigid body and the box collider, let's go and add player input. And we're going to add the horizontal, make sure I spell it correctly, and the vertical. And then also, just like we did for Buckler, we're going to add the player character movement. Great. And just like we did before, we're just going to worry about the bottom portion first, and then we're going to add the upper portion. We're going to drag in the rigid body. Let's truncate this, and we can drag in the rigid body into here. The speed are fine. I'm going to move the smoothing down a little bit. And from here, I think that this should work. Our character at the moment does not jump, so we're going to leave this checkbox unchecked. And if we do this correctly, I hope we did it correctly, we should be able to move our shadow around. Perfect. So it should be moving in relation to our buckler. Now what we want to do is add this separate character. So just to remind you what we were doing previously, we are going to separate our objects. So we established our shadow, and that's moving around great now. And now we want to have, let's say, that if we had Maggie, then we would have Maggie moving around. Not Maggie, Lisa. And let's add, we're going to create a empty child, and this is going to be our main character. You can call it whatever you want. You can do turtle, metalhead, but this is going to be the portion that's going to do the jumping. On here, we're going to add sprite renderer, just like we did for the other aspect, like for our base. So we're going to do sprite renderer. We're going to add, let's do it a little bit at a time. So we're going to add metalhead to here. And we have to set the sorting layer so that it is characters. Make sure that the sprite sort point is at the pivot. If this turtle looks small, it might look small to you. Or if you're using a separate character for your own following along, that's totally great too. Just resize it so that it makes sense to you. And let's just put it somewhere above the shadow right now. Most important thing right now is that it aligns vertically with your character. So eventually we're going to add a rigid body and it's going to want to fall down. So let's just line it up above your shadow. Secondly, let's add box collider 2D at the moment. The most important thing for the box collider 2D is that we have an area that represents our foot or our footing. It can be the full size of our character. We're going to adjust some of these things later when we start to do hit detection and stuff like that. But as long as we have the box collider that's going to be aligning with our feet, when our character falls, it should line up with the shadow's own box collider. With this area right here. Okay, cool. So now back to character. Let's add a rigid body. And this is going to be set to gravity scale is, we're going to adjust the gravity scale because our character is going to fall maybe faster after they jump, and I'll talk about that in a moment. We're going to use mass. Collision detection is going to be important for our characters, especially for hit detection, so we'll turn this to continuous. And let's freeze rotation so that it doesn't spin wildly when we make contact with things. Cool. We're going to add a couple more things. We're going to, on our main character and not the turtle character, we're going to add one more child to it. I'm going to select that and go plus, create empty child. And what this is going to be our way to know whether or not our character is standing on our shadow. And so that allows our character to jump. I've implemented a little bit of ground detection in this movement script, and I'll talk about that in a moment, but we want to add this object so that we can detect it. So we added an empty child, and so this is going to be, let's say, base detector. I've called it base detector, and so this shadow is the base, and we want to know whether or not our character is bumping up against that or not. I'm using ray casting rather than collision for people that are aware of different ways to know when you're standing on things. So I'm using a ray cast, and what's critical is that I want to make this close to my foot and right in the middle of where everything is going to be. I don't need to add anything else. One other thing is go back to my turtle character, which has a collider on it. I'm going to add a layer for physics detection. So my base detector is going to be shooting down a little ray, and it's going to be a really short ray, just a little portion down here, and it's going to be looking for this collider right here, and it's going to look for it specifically. It's a collider that belongs to a certain layer. And so we're going to go to this layer and want to make sure that we have base. Most likely you don't have this layer created, and if you haven't dealt with layers before, we'll talk you through it. So we're going to hit layer, and you can see that there's a layers list, and you can just type in an empty box base, and then go back to your turtle character, because if you add it to the list, it doesn't self-assign it yet. We go back over here and assign this layer to belong to base. And what's important is I only want to assign it to this object only and not any other. I don't want to change it to my children. I just want to add it to this object. Cool. And you'll notice that if we did this correctly, that All the other layers on this turtle character do not belong to base layer. That's really important. Okay, cool. Now let's go back here to the turtle character, and we're going to add some parameters to the fields of the jumping character. Before we had our base rigid body, which is this one here, but now we want to address the rigid body that's on the sprite that's going to be jumping. So in this field here, this char RB, which represents the character's rigid body, I'm going to just drag in the main character, and it's going to find that rigid body. Cool. At this point, we can check does character jump? Yes, it does. And we're going to say that this character has one possible jump, and it's going to jump for a value of 10. If this is the first time that you're using this movement script, I suggest you pick a larger number, just so that you can see whether or not it's jumping or not. I like to pick something ridiculous, sometimes like 100 or 1,000, and if it moves, then that gives me visual evidence that it's working. This on base is a parameter that we shouldn't be checking, but it's going to be a visual indicator of whether or not we are standing on the base. From here, well, below the jump detector is where we're going to drag in the base detector here. This object that we added here, and what it's going to do is going to shoot that little ray from the center of this transform. And so positioning this is going to be critical. Going back here, we have to set a detection distance. And how do we know how far of a distance we need to set this thing? If you can see these gray boxes here, this represents 1 unit. And I only want this detector to be shooting a really short distance between here and here. And I don't want to have it too long, because I basically want my character to be standing on this collider here for me to know when I'm standing on it. If I have it shooting a really long distance, then I'm going to get a false indication of when my character is actually standing on this collider. So going back to here, I want to set this jump detection distance to be something really small. And so for testing purposes, let's just set this to be 0.1. Once we hit play, oh, there it is. So I have it drawing a gizmo to let you know how far this is. And maybe this is already a little bit too far. This is going to be a white line, and I have it drawing on gizmos. And fool around with this until this makes sense or visually lines up with just a little bit of portion below your character's foot, so that this ray, when it shoots, if it hits this collider, then it'll give an indication of whether or not you're on base. Last thing that we want to do, or a couple last things we want to do, is change the detection layer. Remember when I said that we added this collider or this object to belong to a certain layer, and we added it to be base? We want to make sure that we actually are looking for the base layer when we are checking to see if we're standing on this collider. From there, our jumping gravity scale is really important. So this means that when our character actually jumps, do we want to have a gravity scale that makes our character feel floaty or feels like it's really heavy? So what I like to do is set a jumping gravity scale. This is when the gravity scale of when your character is jumping upward. When that happens, I want to set it typically to be 1, and I want to change the falling gravity scale to be maybe 2 or 1.5. Most games that you've played, including Mario Bros, is that when Mario jumps, its falling rate is faster than its jumping rate. And so maybe in your game you want to have that sort of feel, then that's what you would change. If you wanted to feel all the same, then just set both of these to be 1. Oops, not 11.5, 1.5. Cool. Last thing is go to player input, and let's change this jump button from none to space. You can set it to whatever you want. You can do tab or something weird like P, but make sure that you assign it to something. I think we're almost there, and let's just see if this works. Oh, you can see my turtle is falling down. What do I need to change? We need to change my turtle character's rigid body. And the gravity scale is 0. So what's the thing that I need to change then? Is it my main character's rigid body? Dynamic. Let's see, what did I do for my original one? Okay, cool. I need to go to my character, this character's rigid body, and change it from dynamic to kinematic. Cool. So this is obviously a very high jump. So when I said 100 or 1,000, I was kind of joking. But let's go back to here and let's change your jump value to something more reasonable. I changed it from 10 to 4. So now our character is jumping. Fool around with this, and you can change your possible jumps to whatever number that you want. Right now I changed it to 3, so my character can jump 3 times. Most likely, many beat 'em up style games have around 1 or 2. That's very common. Oftentimes you don't see more than that, just percentage wise. So fool around with that and get a feel for where you want. Make sure that you play around with some of these jump heights. Again, change your H speed and vertical speed and your movement smoothing. This is going to be based on when your character is on the ground. So your character should be able to move around on the ground, no problem. And that's going to help your character move around. Next episode, we're going to talk about putting some other colliders that are going to interact with the character's base collider, so that you don't want your character to move off the ship or any sort of visual boundaries that you have. And we're going to talk about that. And then next episode, we're also going to be talking about hit detection. So knowing when your character gets hit and maybe taking damage, those sorts of things. But we really wanted to set this up being able to jump, and hopefully this works for you. Like and subscribe if you haven't already, and please follow along. I'm gonna try to put out some more videos more often than I have. This pandemic has really, slowed a lot of stuff down, but I want to be more frequent in how often I update these videos. So if you have any questions or like to see a different portion of this, we are going to be talking about different types of colliders and detecting when we are hitting different boundaries and ultimately taking damage from other characters. Cool. I'll talk to you guys later.